unsupervised learning. Let's do that now. Let's do that now. Supervised learning is going to take us about 4 slides because I'm only going to talk about one method. The hardest part about unsupervised learning is figuring out what the hell it is, I think. And this is a little interlude of philosophy. Learning. What is learning? It turns out, I haven't done this, but there have been scientists who experiment on their children. I love my children, so I don't do this, but there's like a guy at MIT that got money from our government to go bug his house and put video and microphones everywhere, and he's recorded every word that has been said to his child for the first 3 years of life. So if you want to study how this child learned how to speak English, you have the data. People make all these claims about how, oh, well, children never hear blah, 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 and yet they're able to blah. Well, actually, it turns out every once in a while somebody does say that to the kid. And so, but I don't do that kind of stuff. It is kind of rare, though, that you will see a parent going out into the world with a child and saying, that's a chair. That's not a chair. That's a chair. That's not a chair. That's a peanut butter sandwich. This is not a peanut butter sandwich. Like, children get very little negative examples, very few negative examples of things. Like, there are lots of things this is not, and I'm not going to sit around and enumerate them, right? We'd be here forever. So how do people learn stuff, right? Supervised learning isn't necessarily applicable in all situations. There are situations where somebody just drops you on Mars, data comes at you, and you're supposed to figure it out. So what the hell does figure it out mean? And that's what unsupervised learning is about just figuring it out. What does figuring it out mean? What?
It means beating the system.
Beating the system. So yeah, in a sense, so you have this data stream coming in, and you're like, data! So what we're going to do is basically unsupervised learning is compression. To beat the system, you want to understand what's going on enough that you can predict what's going to happen. When a scientist says that he understands something, that means he can predict what's going to happen. If you understand the program you wrote, then when I give you 1 million training examples, you can predict the runtime for me. Right? Is it going to be quadratic? Is it going to be linear? Is it going to be exponential? As a computer scientist, you should know this. You'll understand the artifact that you have created. As someone who knows about the passing of the seasons, if I tell you it's July, you can predict the high temperature of the day. Right? It's not going to be 40. It's not going to be 60. It might be 70, might be 80, might be 90. I don't know. It depends a little bit. But we have some idea. If it's January, it's not going to be 100. Right? It's going to be 30 or 20 or 15 or negative 10. So to understand something means to be able to predict stuff about it. Whenever you can predict, you can start to compress, as we talked about when we studied entropy. So unsupervised learning is basically building a model of your data, a small, compact model. So and I hope this doesn't confuse things. One way of understanding this data set is by that red line there. We've now compressed the data. It's a lossy compression. And now if I remember that line, then I've compressed the data set. So that's the philosophy behind unsupervised learning, is to try to understand the data. to try and discover structure in it so that we can predict what's happening in the data. What's the next element going to be? Yeah, Dan.
So is unsupervised learning like knowing that chairs go with tables? And seeing something at a table and saying that's a chair?
Unsupervised learning is seeing lots of objects and then recognizing, oh, there seems to be this class of things that people sit on that have backs. And there seems to be this class of things that people put their plates and silverware on. And those are maybe different kinds of things. And people seem to say the word chair when they're talking about grabbing one of them, and they seem to talk about tables when they're doing other things. So maybe that's a table and this is chairs, and they're different classes of things. And when I go to the store, they might have a chair section and a table section. That's unsupervised learning. Discovering regularities. Oh, there seems to be spring. That's when it's muddy out. Ah, it's summer. That's when the air conditioners are on. Ah, it's winter. That's when people are complaining and slipping and breaking their limbs. Dylan, do you have a question?
Yeah. So if a linear model is a lossy compression, what would be a lossless compression?
So if your hypothesis space is expressive enough to capture all the data, then your compression will be lossless. Usually that's a bad idea, because there's usually a little bit of noise in the world. Someone shows you these things that are obviously chairs, and he calls them stools just because their legs are really long. Something like that. Okay, so I'm going to use for this class the example of clustering as an unsupervised learning problem. Somebody gives us a mass of data and says, figure out what's going on in this data. And you're trying to see, well, gee, what is going on in this data? Do there tend to be clumps? Can I simplify, can I compress this data by just saying, oh, there are chairs and tables and automobiles, and rather than remembering everything about every object, I'll just remember, oh, that was a big white car. And I've shortened my description of the object by having the concept car. Right? So that's a way of compressing. I don't know if you guys, I don't even know that much about JPEG 2000. I think it's an object-oriented compression format. It's, I think it was supposed to be designed to do well with video, so that like you would send the background as one frame, and then you would send the objects that were in the foreground and where they were. So that if you had something moving in front of the background, you never had to send the parts of the background that were appearing as the object moved. You would just send that the object was moving. So it's like a very high compression ratio. Just a wonderful file format. I don't think it's caught on a whole lot, but I don't really know how H.264 works. So for all I know, it has elements of that as well.
Maybe